Hello everyone. There are several ways in which one could achieve the same model in CST or generally in CAD design, and you could go through different steps. For example, if you wanted a cylinder, you could either go through sketch, you sketch a rectangle and then sweep it around, or you could use a primitive. So just defining a cylinder from here. Now I think I already mentioned this in an old video, but then you have different techniques. So there's no one technique that kind of describes, okay, you have to do it, you must do it this way. However, some techniques yield better results than the other. What do I mean by better results? Better results in the sense that they are easily modified at a later time than others. What I'm going to be talking about today is, so for example, I have this model. I'm going to talk about a different way in which this could be modeled. Now, in an earlier video, or in most of my videos that I model some devices, I of course start with a model like this, which has already been dimensioned. Now, I also mentioned in those videos that you should try to create your dimensions so that they are all independent of each other, in the sense that you do not have one variable depending on the other, that when you change, like for example, if I change L3, what I expect to change is just the length of this stub here and not any other thing. But then you could also make some models and some parameterizations that you could change L3 and then it ends up changing, let's say OL2. So you have those kind of relational dimensioning. So that it's not really okay, because then you can't control exactly what you change. You cannot predict the outcome of any change to the geometry. However, that is not what I'll be talking about today. In most of my videos, you see that I start with this diagram, and then what I do is I kind of create a relational. So when I model each of the parts, I use relational dimensions, in the sense that I start at a base point. So usually I start at, I think I could I minimize this? Yeah, I'll take this out of the way. So what I usually do is I start with let's say a cylinder. Okay, now I do not have any of the variables defined, but I'll just, yeah, wing it along the way. So I would have Ri and then let's say Z mean, let's say I don't know, maybe minus, okay, I have to use the dimensions. Let's say beam pipe, or just say beam pipe length. So beam pipe length, so just winging this, and then beam pipe length. Minus and plus, I usually try to, or I prefer the model center, because then it makes easy for other things. So I could say 150 millimeters. I hope that's millimeters, yes. And then a beam pipe length, let's say 100. I know, just putting in any value there. Okay, that is supposed to be pec, but no matter, I could still change it from here and change this to assign material and color. So I change it to vacuum. Mate, it doesn't matter. So this is what I have. Okay, I think I need to turn down the illumination. I was making a video earlier about these, so I turned this up, and then yeah, I think okay, yes. So I have this. Should I save it? Modeling. No, just save it fun with WCS. Now this is what I have, and then which is this part of the model. So this is a high order mode coupler, coaxial coupler. So I the Y model is usually I take the 0 point as a reference and then take everything as an offset. So for example, let's say I wanted to model this cylindrical section and this pipe on top of it. What I do is I go to cylinder, I go to modeling, and then cylinder, and I change the orientation to Y from my axis. I change it to Y, and then I have the radius. I think it's RCH. I don't know. I'll just call it RCH for radius of the chamber. And now calculating Y mean, I could leave Y mean as, I usually leave Y mean as 0, which is at the center. And then Y max. How do I get Y max? What I do is I have to where is it? So for y max, what I do is I calculate the offset from here to the very top. So that becomes, I use ri plus, so the radius of the beam pipe plus the all the radius of the all the lengths of the section of the coaxial coupler sections, and kind of calculate it, and then I get finally the height of the chamber. So I think I could just put length or height. I use h of chamber. So but then I use it as, so in my models you see it's something like ri plus li plus l1 plus any other thing, right? I just have that. And but here I'm just going to put, I'm not going to calculate it, so I'll just put hch and preview. Let's say rch, this was 100, so maybe I'll use 80, and lch, let's see, 300. I'll adjust it if, so this is what I have. Apply to all, no. So I mean, I could of course boolean this, but then I usually leave all the boolean operations and all the um, edge operations, which is like chamfering or rounding the edges. I usually leave it for the last. So that's the last step I usually take. Otherwise, it causes problems also sometimes building the model. So that's also something that you have to keep in mind. Now, I could do that and then just try modeling the other. So the point is, for most of my models, I take kind of a reference point and then make all the other components relational, which is usually easy for me. But then one thing that you could also do is maybe get another reference point. And so for example, okay, this is maybe a bad example to show this, but I would, let's say I wanted to continue building from this. So let me reduce it a bit so the model doesn't get too long. So it's 150, so I'll use 200. Let's say I had a geometry that's yeah, parametric update that was structured like this, and then you had some other reference point at this point, and then you could build on top of it. I use the one I use because it's, I don't know, for me it's the easiest, but then I'm just showing another way that you can do it. So let's say you had a model that had some geometry like this, and then the other components you had kind of stacked up on top. So one thing that could be done is still start from the reference, and for example, let's say I wanted to put another cylinder on top of this. Yes, that's a good example. So what I'll do is I would define this as, let's say, RCH2, so a second radius, so we see the difference, and then orient it Y, and then Y mean, I would now set Y mean as the last dimension, the last vertical dimension, which would be this point. So I would set Y mean as HCH, and then I would set Y max as let's say is HCH2, so the height of the second cylinder, which is on top of it. And if I should preview this, then RC2, I want to make it smaller, so it was 80 before, let's make this 60. And the height, I'll make it 100, or let's say 50. So if I should preview this, what's this? So HCH2, this, okay, it's not supposed to be 50 because I'm taking my reference from the center. So even if the height of the cylinder is 50, I have to make it 150 because it's the total length. So I'm taking it from the reference. So HC2 becomes, no, I think I'll just start this again. So I'll start this again. So what I have is cylinder, and then RCH2. I hope I still have that defined. Yes, so RCH2 Y. Yeah, I missed something. So the Y min becomes the last dimension, then the Y max becomes the last dimension plus the new dimension, so HCH2. Yeah, this is how it's supposed to be. And then you see that this appears nicely on top of this, which is what I want, of course. So it's kind of this way. I take the reference from the 0 point and then just keep building up on that. But then what could be done instead? So I would have, should I save this? Yes, I'll save this. So this is what we have. But then this same result could be gotten by, let's hide this, and then let's create another model. So instead of having to build from one reference point, which is what I usually do, because it's I don't know, I think, why do I do that? Okay, I don't know, it's just what comes naturally to me. That's what I do, and I calculate everything. But what you could also do is you could also align your coordinate to this point, and you could do a local coordinate. You could, no, not this, you could align, go to align world coordinate system. So align world is it world? Yes, world coordinate system to, so that's the WCS, to selected face. So now I have a new coordinate system, right, with new coordinate directions, which is UV and W. So I could now model a cylinder and escape. So what I have is I want it pointing in direction W, which is what you already see here. And then what I have is the outer radius, which should be RCH2. And the W mean 0 because my reference system is now 0 at this phase. And then the max just becomes HCH2. No, I typed this wrongly. Yes. So preview, and you see we have exactly the same result. So this is exactly the same result. Now one thing that, so I'll save this. So it's exactly the same result, but then this is no longer relational. I mean, if your model is easier to model this way, then this would come in handy. So after this, I could now turn on the local world coordinate system, and then it goes back to the zeros that I have. And we have solid 4 and solid 3, they're exactly the same thing. Yeah, that was it. But then one other thing is that, let's say, for example, you wanted to make this your reference for so many other features that you want to put on top. Then you could actually save um, the coordinate system. So for example, if I should go to, okay, let me model on this. So I go to this and then I align the system on the selected face. Then what I could do is I could also store this coordinate system and I could call it, yeah, WCS1. And then when I store it, it appears here. And then I could switch to this coordinate system at any point in time. So for example, I go to this and then let's say I want to get, okay, this is local coordinate system, but no, no, this should, so this is selected now. I think if I should select out of it, yes, then it goes back to the world coordinate system. So if I wanted to model anything, now it starts from here. But then if I should select this, then I have the coordinate system. So the local the coordinate system I saved, I have it now selected. And if I want to model on top of this, then I have to select that it should use the local coordinate system. So let's see, let's just as an illustration, if I do not select this, let's see, and I wanted to model this, I would go to, you see, you already see that the orientation and the coordinate system is using is still the global coordinate system, which is your XYZ, because even though this is, I mean, it's showing it's selected, but then I have to still select it from here that it knows to use the WCS1. So yeah, let me just model something else on top, because why not? You see, it's WCS, the UV and W. So I could say this is RCH3, and then I could call this HCH3. And let's see, what am I missing? So preview RCH3, make it even smaller, 40, and HCH3, make it let's say 50 also. Okay, and preview, voila, we have that. Now I want to create a new word coordinate system on this face. So we have two coordinate systems. So I have this the same. Go to align with selected face. Yup. And then let's say I store the current coordinate system as WCS2. Now, if I go back to your components, then it's the world coordinate system. Now, if I want to build something on top of this face, which is what I save as this coordinate system, sorry, the second one, then I have this, and then I would have to align it to the second. Now if I should click on the first, then it aligns it to the, do I have to select it? I think, wait, I think, yeah, local coordinate system, I think this should be selected. Now I have to test that because it's still showing this, but yeah, I'll have to test this, and let's see where this one builds on. I go to cylinder, and let's say I wanted to do, so it's WCS, but then where is the WCS here? Which one is it selecting? It's not showing, but let's see, what should I do? RCH4 and HCH4. Now let's make this 20, and I'll make this, let's say, 200. Yeah, so you can, I don't know if I can really, yeah, I have to complete this operation. So it's starting from the coordinate system selected, which is, yeah, what I expected. So, aha, no, it's not. It's starting from the last coordinate system, which is not what I expected. Wait, I think I did something wrong. So it's still starting from the WCS2. Yeah, so it's still starting from the WCS2. Why is that? Oh, I think, yeah, I missed something. So it's starting from the WCS2 because that's the latest world, I think, is this world coordinate system? I think so. I think that's what it's called. WCS, I'll just call it WCS because I'm not sure it's world again coordinate system. I'll just call it WCS. So it's starting from the latest WCS because that's the last we use. So it's still recording that as the local coordinate system. Now, in order to get it back to maybe previous coordinate systems that we do, this is what I forgot to do, is that you have to right click and then restore. Then it selects this as the local coordinate system. So now let's test that again. Let's see. First I'm going to, yeah, so that we can see it, I'm going to highlight the other ones out. So I go to modeling and then escape. Then I have RCH5 and then HCH5. So this would be RCH5. I want to make it 10, and HCH5 I want to make it 200 also. So you see, it starts from this new coordinate system, and yeah, that's basically how you stack up. So if you had, I don't know, 10, a million world coordinate systems, then for you to specify this coordinate system as a local coordinate system, then you have to first restore. You have to first restore it, and then it becomes the default local coordinate system, and that's how you toggle also between coordinate systems. So I think in general, I think it depends on the model that you are, what you are modeling. I think some models are easier or and more also more intuitive building up this way, but I do not think that is the case for um my, I mean the higher order mode couplers I design. No, I mean it could also be the case, but then getting the first dimension I still have to calculate. So for me it's easier because I already calculate the whole length, and then what I just do is I just copy and then paste, delete some of the dimensions from this entire length which I have already calculated. So I think that's why it was natural to me. I don't know, but then you may have different model, and then this might be more effective. And then if you want to go back to the world coordinate system, then you just click this and you can return to any of the coordinate systems later. You could also name it, you could also give it a nice name so that you remember exactly what it stands for. So that was it for this video with this very, oh wow, what's this looking like? It's looking cool actually, the model we ended up with. But yeah, this is just a construed example, and yeah, you could use it to do more complex things. So that was it for this video. Hopefully through all the ramblings you learned one thing or two from the video. Okay, see you some other time.